Hello everybody, today we're going to talk about the dry principle. Now I'm going to try to touch on the dry principle from a very different angle that you might have never heard before, because I think that the dry principle is one of the most misunderstood concepts in software engineering, and it's also one of the most common principles in software engineering. New software engineers are being taught this principle probably from the very first day that they're being taught how to code. But I do think that there are many cases when duplicating code is not only fine, it's actually better than not duplicating it. So with that being said, let's get into this and talk about the dry principle. The dry principle was originally formulated by Andy Hunt and Dave Thomas in their book, The Pragmatic Programmer. It's a very old book, but they do have a second edition which has been renewed. And in the second edition, they talk about how their definition of the dry principle in the first edition has been misunderstood by many. Many people think that the dry principle is about duplication of code. So if they see two different places where the same code is used, they think that this is a problem because you have a violation of the dry principle. And on the surface level, you do. You have two different places that are using the same piece of functionality twice, and if we look at it only on the surface level, that doesn't look like something logical to do. Why would you want to duplicate code and write the same piece of code twice when you can just have it in one place? Moreover, duplicating code has actual disadvantages. If you have the same code used in two different places, what happens when you want to make changes to that code? Now you will need to change it both in place A and in place B and in place C, etc. So duplicating code has a price, and by not duplicating code, essentially, whenever you want to make changes to that code, it will propagate everywhere else. So far, it sounds like duplicating code is something really bad and something that you should never do. Well, is that the truth? Not really. Like most principles, these things have trade-offs. There are trade-offs. There are advantages to duplicating code. There are disadvantages to duplicating code. And it all comes down to one basic, simple design concept called coupling. Let's say you have component A and component B, and you notice that both of these components are using the same method to do the same thing with the same business logic. So what do? You think the dry principle. Let's take this and reuse this. You put the code outside, component A imports that code, component B imports that code, there's no code duplication, and you're happy because you think it's the best decision, but in fact, you just created coupling between component A and component B. Now they're coupled. Every change that you will want to make in that business logic that where the coupling exists will happen in both places. This can be good, but this can also be bad. Coupling always has trade-offs. We've talked about the good side, the advantages of coupling. It makes changes a whole lot easier, but what are the disadvantages? Whenever you create any kind of coupling between two entities, it makes the evolution of those entities separately very, very hard. So the disadvantage of coupling is that it makes separate evolution hard. Let's take our previous example. Let's say we have component A and component B. Let's say that they have duplication of code. They have the same method both in component A and both in component B. And let's say component B wants to take that method and had a whole lot of business logic there. They want to do different things than component A. Because there is no coupling between them, component B is isolated from component A, they can make whatever changes they want without having to worry about anything. But let's say we did try to implement the dry principle the wrong way, and we did create coupling between them. Now, component A and component B both has the same method, but they use the same implementation. So if component B wants to do something completely different, it's not going to be possible, or it's going to be very hard, or it's going to be very messy, because component A also uses that same business logic, and component A wants to do something else. So this is exactly where the trade-off lies. You see, if you have two different entities and one of the entities want to evolve separately, if you created coupling, then you're in problem. And maybe it doesn't sound so bad when we talk about one method, but in real life, code is much more complex than that. Coupling has much more effects than that. The method is just one example, but in real life, in complex code, when you create coupling and then you want to evolve things separately, you're going to have a very, very hard time. So how can we turn this into a system? How can we give this a bit more order so we know when to couple, when to decouple, and how to actually do this? The decision about whether to decouple or couple should all come back to the design and the basic design fundamentals that your code should reflect your policy, your entities, your interfaces. So if you're developing some kind of system for students and teachers, a student is an entity, a teacher is an entity. And while they may have similarities, for example, they both have a list of the classes they attended, it has very different meaning and very different implications to what it means for a student and what it means for a teacher. And therefore, because those are different entities, even if you have the same functionality, you want to isolate between them. You don't want to couple, you don't want to create coupling between two different entities. You only want to create coupling between the same entity. Now, this doesn't mean that you should not reuse code, right? You should create utility classes. You should create utility service. If you can take a piece of functionality and extract it and reuse it, awesome, amazing. The point here, the thing is, you don't want to take your entity's business logic and reuse that. Why? Because you want to allow for future evolution of your entity. And even if it looks exactly the same, it's much better to have it separately, because at the end of the day, you want your code to stand the test of time. You want your code to be easy for changes, easy to refactor, because code does change. Changes will happen, refactor will happen, entities will evolve, and the more isolated they are with their business logic, the easier it will be. Now, after we understand all of that, let's take a step back to dry. Dry is not about duplication of code. Dry is about duplication of knowledge. And I love that sentence. That's what Andy Hunt and Dave Thomas really emphasized in the second edition of their book. And I think it's absolutely correct. Duplication of knowledge is horrible when you have the same entity that has the same business logic but different places are duplicated for that. It's bad, because when you want to evolve that entity, you're gonna have to evolve it in all these different places. But duplication of code is absolutely fine and even encouraged when you have two different entities that you want to allow them to evolve separately. I hope you enjoyed this video. I sure did, and see you next time.